Hey everyone, welcome back to the video. So today I will be explaining Physics Paper 4 Code 0625 Paper 41 May June 2019. Let's get started with the first question. Question 1 states a rocket is stationary on launch pad at time t is equal to 0. The rocket launch engines are switched on and exhaust gases are ejected from the nozzles of the engine. The rocket accelerates upward. Figure 1.1 shows how the acceleration of the rocket varies between the time t is equal to 0 and the time t is equal to tf. So over here we have the figure 1.1. Part A states define acceleration. Acceleration is defined as the change in velocity per unit time. So this is what we'll write in part A. Part B states on figure 1.2 sketch a graph to show how the speed of the rocket varies between time is equal to 0 and time is equal to tf. So over here this is the graph with the sloping curved upward line. So this is how we will draw a line sloping upwards in question part B. Question C states sometime later the rocket is far from the Earth. The effect of the Earth's gravity is on the motion of the rocket is insignificant. As the rocket accelerates, its momentum increases. Part 1 state a principle of conservation of momentum. In an isolated system, the total momentum remains constant. So this is what we'll write in part 1 of question C. Part 2 states explain how the principle of the conservation of momentum applies to the accelerating rocket and the exhaust gases. The rocket gains upward momentum as it moves upwards. The ejected gas gains equal momentum in the opposite direction. So this is what we will write in part 2. Question 2 states figure 2.1 shows a sign that extends over a road. So this is the figure 2.1. The mass of the sign is 3.4 times 10 to the power of 3 kg. Part A states calculate the weight W of the sign. So weight is equal to m times gravitational force, which is 3.4 times 10 to the power of 3 multiplied by 10, which is 3.4 times 10 to the power of 4. Then part B states the weight of the sign acts at a horizontal distance of 1.8 meters from the center of the support post, and it produces a turning effect about point P. Point P is a horizontal distance of 1.3 meter from the center of the support post. Part 1 states calculate the moment about P due to the weight of the sign. So moment is equal to force times perpendicular distance from the pivot. So force is 3 times 4 times 3.4 times 10 to the power of 4 multiplied by 1.8 minus 1.3, which is 1.7 times 10 to the power of 4. So this is what we will write in part 1 of question B. Part 2 states a concrete block is positioned on the other side of the support post with a center of mass a horizontal distance of 70 cm from the center of the support post. One state what is meant by the center of mass. Center of mass is the point where all the mass can be supported to be concentrated. So all the mass should be supported to a concentrated location. Then second states the weight of the concrete block produces a moment about point P that exactly cancels the moment caused by the weight W. Calculate the weight of the concrete block. Clockwise moment is equal to anti-clockwise moment, hence moment is equal to 1.7 times 10 to the power of 4. So the moment is equal to force times perpendicular force. 1.7 times 10 to the power of 4 is equal to force times 1 plus 1.3 plus 0.7. So the force will be 1.3 multiplied by 0.7 divided by 1.7 times 10 to the power of 4 and is equal to 8.5 times 10 to the power of 3. So the weight is 8.5 times 10 to the power of 3, which will be newtons. Then question C states the concrete block is removed. The sign and the support post rotate about point P in a clockwise direction. State and explain what happens to the moment about point P due to the weight of the sign as it rotates. The moment about the point P increases because the perpendicular distance between P and the line of action of W increases. So this is what we'll write in part C. Question 3 states a cube of side 0.04 meters is floating in a container of liquid. Figure 3.1 shows the surface of the liquid is 0.02 meters above the level of the bottom face of the cube. So this is the figure 3.1. The pressure of the air above the cube exerts a force on top of the face of the cube. The valve is closed. Part A states explain in terms of air molecules how the force due to the pressure of the air is produced. Air molecules collide with each other. They also collide with the upper surface of the wall of the cube. This causes an impule on the surface of the block. So this is what we will write in part A. Part B states that the density of the liquid in the container is 1500 kg per meter cube. Calculate part 1 pressure due to the liquid at a depth of 0.028 meters. So pressure is equal to HPG, which is 0.028 multiplied by 1500 multiplied by 10. That will be 420 pascals. Part 2 states the focus on the bottom face of the cube caused by the pressure due to the liquid. So force is equal to pressure times area. Pressure is 420 pascals multiplied by area, which is 0.04 squared, which will be 0.67 newtons. So this is what we'll calculate in part 2 of question B. Part C states the valve is open and the liquid is pumped into the container. The surface of the liquid rises to a distance of 0.034 meters. The cube remains floating in the liquid with its bottom face 0.028 meter below the surface of the liquid. Part 1 states calculate the work done on the cube by the force in B2. So work is equal to force times distance, which is 0.67 multiplied by 0.034, that is 0.023 amount of work done. Part 2 states suggest one reason why this is not an efficient method of lifting up the cube, because there exists friction between the liquid and the container. So this is what we'll write in part 2 of question C. Question 4 states the gas of mass 0.23 grams is trapped in a cylinder by a piston. The gas is at atmospheric pressure, which is 1 times 10 to the power of 5 pascals. Figure 4.1 shows the piston held in a position by a catch. The volume of the trapped gas is 1.9 times 10 to the power of minus 4 meter cubed. An electrical heater is used to increase the temperature of the trapped gas by 550 degrees Celsius. So part A states the specific heat capacity of the gas is 0.72 joules per grams degree Celsius. Part 1 states calculate the energy required to increase the temperature of trapped gas by 550 degrees Celsius. So E is equal to mass times C, which is the specific heat capacity, multiplied by change in temperature. So 0.23 multiplied by 0.72 multiplied by 550, that is 91 joules. So the energy is 91 joules. Part 2 states the power of the heater is 2.4 watts. Calculate how long it takes for the heater to supply the energy calculated in A1. Power is equal to E divided by time. So we have to calculate how long it takes. So T is equal to E divided by P. Energy is 91 and power is 2.4. So 91 divided by 2.4, that is 3.38. So 38 seconds. Then second question states in practice it takes much longer to increase the temperature of the gas by 550 degrees Celsius using the heater. Suggest one reason for this. Thermal energy is used to increase the temperature of the surroundings. So this is what we'll write in part 2. Part B states when the temperature of the gas has increased by 550 degrees, the pressure is 2.9 times 10 to the power of 5 pascals. The catch is then released, allowing the piston to move. As the piston moves, the temperature of the gas remains constant. Part 1 states, state and explain what happens to the piston. The piston moves to the right because the resultant force is to the right. So this is what we'll write in part 1. Part 2 states determine the volume of the gas when the piston stops moving. V2 is equal to P1 times V1 divided by P2. So 2.9 multiplied by 10 to the power of 5 multiplied by 10 to the 1.9 multiplied by 10 to the power of minus 4 divided by 10 to the power of 5 multiplied by 1. That is 5.5 times 10 to the power of minus 4 meter cube. So the volume is 5.5 times 10 to the power of minus 4 meter cube. Question 5 states liquids and gases are two states of matter. A states in both boiling and evaporation, a liquid changes into a gas. Part 1 states two ways in which boiling differs from evaporation. First is boiling happens throughout the liquid. Second is boiling happens at one temperature. Part 2 states before injecting a patient, a doctor wipes a small amount of volatile liquid onto the patient's skin. Explain in terms of molecules how this procedure cools the patient's skin. More energetic molecules escape from the liquid because they overcome the intermolecular forces. Part B states gases can be compressed but liquids are incompressible. Explain in terms of molecules why liquids are incompressible. Liquids are incompressible because the molecules touch each other, hence large repulsive forces exist when the molecules are moved closer together. So this is what we'll write in part B of question 5. Question 6 states green light of frequency 5.7 times 10 to the power of 14 Hz is traveling in air at a speed of 3 times 10 to the power of 8 meters per second. The light is incident on the surface of the transparent solid. Figure 6.1 shows the wavefronts and the direction of travel of the light in the air. So this is a diagram of figure 6.1. Over here, this wavefront is coming towards the air and solid boundary, and over here it is refracted. The light travels more slowly in the transparent solid. Part A states explain in terms of wavefronts why the light changes direction as it enters the solid. You may draw on figure 6.1 as part of your answer. One point of the wavefront hits the solid first and is also slowed down first. Therefore, the angle of the wavefront changes. So because once the wavefront hits the solid line, over here it slows down, so it refracts or bends towards the normal line. Then part B states the refractive index of the transparent solid is 1.3. The light is incident on the surface of the solid at an angle of incidence of 67 degrees. Calculate the angle of refraction of the light in the solid. So n is equal to sine I divided by sine r. Then n is multiplied by sine r is equal to sine I. Then sine r is equal to sine I divided by n. Then r is equal to sine and sine inverse or minus 1 brackets open sine and sine I divided by n brackets closed, and the answer will be r is equal to sine inverse brackets open sine 67 divided by 1.3 brackets closed, that is r is equal to 45 degrees. So the angle of refraction is 45 degrees. Part 2 states determine the wavelength of the green light in the transparent solid. So VTS is equal to C divided by N. So 3 times 10 to the power of 8 divided by 1.3, that is 2.3 times 10 to the power of 8. Then wavelength is equal to V divided by force or F. So 2.3 multiplied by 10 to the power of 8 divided by 5.7 multiplied by 10 to the power of minus 14. That will be 4 times 10 to the power of minus 7 meters. So the wavelength will be 4.0 multiplied by 10 to the power of minus 7 meters. So this will be the final answer. Question 7 states figure 7.1 shows a circuit diagram that includes component X. So this is the figure 7.1. Part A states state the name of component X. So the name of the component X is thermistor. So the answer will be thermistor. Then part B states the electromotive force EMF of the battery is E. The switch is closed. The potential difference PD across the 30 ohm resistor is V30. The PD across the 20 ohm resistance is V20. PD across the component X is Vx. So state an equation that relates Vx to V30. So Vx is equal to V30. Then part 2 states E is equal to V20. So Vx is equal to E minus V20. So this is what we will write in part 2 and part 1. Question C states the EMF of the battery is 6 volts and the resistance of component X is 15 ohms. Calculate part 1 the total resistance of the circuit. So I divided by R1 plus I divided by R2 is equal to I divided by RFOT. So 1 divided by 15 plus 1 over 30 is equal to 1 divided by RTOT. So 30 plus 15 divided by 30 times 15, and this will be 30 plus 15 is equal to 30 multiplied by 15, that will be 10. So 10 plus 20, which is 30 ohms. So the total resistance of the circuit is 30 ohms, and this will be the final answer. Part 2 states the ammeter reading. So I is equal to V divided by R. So V is 6 and multiplied by 30, that will be 0.2 amps. My bad, over here it's 6 divided by 30, so that will be 0.2 amps. So the reading will be 0.2 amps. Question D states the temperature of the component X increases. State and explain what happens to the ammeter reading. The ammeter reading increases. This is because the total circuit resistance decreases. So this will be the final answer for question D. Question 8 states a student turns the handle of an alternating current AC generator and the coil rotates. Figure 8.1 represents the structure of the AC generator. So this is the figure 8.1. Part A states there is an alternating voltage output between the two terminals. Part 1 means explain why rotating the coil produces an output voltage. So the answer will be the magnetic field exists between the two poles of the magnet. The coil cuts the magnetic field and hence an EMF is induced into the coil. So this is what we will write in part 1. Part 2 states the state the position of the rotating coil when the alternating output voltage is at a maximum value and explain why the maximum output occurs at this position. So the answer will be the maximum output voltage occurs when the plane of the coil is horizontal. This is because it is in this position that the magnetic field cuts the coil the fastest. So this is what we write in part 2. Question B states a lamp and an open switch are connected in a series to the output terminals of the AC generator. The switch is closed and the lamp lights up. The student has to apply a greater force on the handle. Explain why a greater force is needed to keep the lamp lit. Because the energy is lost to the lamp, hence the student needs to supply more energy. Also, a greater force is needed to do this work. Why? Because once the student puts energy into the lamp, it lights up. But if he doesn't or she doesn't keep that energy constantly, so the light will not be turned on constantly. So this is what we will write in part B of question 8. Question 9 part A states figure 9.1 shows a beam of alpha particles moving towards a thin sheet of gold in a vacuum. So this is figure 9.1 with detectors and a vacuum with a beam of alpha particles and a gold sheet. Detectors in the region surrounding the thin sheet detect the alpha particles and determine the number of particles that travel in various directions. State and explain what can be deducted from the following observation. Part 1 states the majority of the alpha particles pass through the gold sheet undeflected and are detected on the far side. Why? Because in deduction nucleus is very small. Explanation will be very few alpha particles hit or pass near to a nucleus. Then part 2 states a small number of alpha particles are deflected as they pass through the gold sheet. Deduction is the nucleus is charged, and the explanation is charged alpha particles experience a force. Part 3 states a very small number of alpha particles are deflected through very large angles or return back the same way they came. Deduction will be nucleus includes most of the atom. Extension will be alpha particles move and the nucleus stays still. So this is what we'll write in question 9 part A 1, 2 and 3. Question B states a beam that consists of both alpha particles and beta particles is passed through the region of space where there is a magnetic field perpendicular to the direction of the beam. State two ways in which the deflection of alpha particles differ from that of the beta particles. So first is opposite direction, second is much smaller deflection, and third is undergo reflections of smaller magnitude. So these are the three ways in which the deflection of alpha particle differs from that of the beta particles. So guys, if you like this video, don't forget to subscribe, like this video and share it with your friends who are also interested in these type of videos. See you in the next video. Bye.